Assalamualaikum warahmatullahi wabarakatuh, and good day to everyone. My name is Syaiful Anas bin Suhaimi from the Engineering Department, University Malaysia of Computer Science and Engineering. So today I will present about the smart pill dispenser with monitoring system for senior citizen. Before I would like to go further for this presentation, I'd like to thank you to ISWTA 2021 committee to give me this opportunity and accept my publication paper. Alright. So first, I'd like to explain about the problem statement for this project. Alright, so the problem statement will focus on the senior citizen. Some of them take matters into their own hands by changing the dosage or finding alternative in getting the medication they think they need, and they regularly forget to take their medicine self. All the dispenser is a great alternative to solve the problem because it tries to wipe out or at least minimize the error that might occur during the process of placing the pills into the compartment or dispensing the pills. The problem with the existing pill dispenser that they do not have any different colors of indicator to differentiate the due time of taking the pills, where the user cannot identify the duration of the delay pill. This is really important to ensure the effectiveness of the pills, since the pills are supposed to be taken at prescribed time. As the longer the time delay, the less effective the pills will be. Besides, existing devices are very complicated to use and the operations are limited. Some of the devices use a small alphanumeric monochrome screen and some button, which can be confusing to the senior citizen. Next, the setup process for existing devices must be repeated when a parameter changes. This can be very difficult for senior citizens to use by themselves due to their age and limitation. Whereas these devices are error prone and the result of small mistake can be catastrophic. To cater these problems, a smart pill dispenser with a monitoring system for senior citizens is developed. So as what you can see from this figure, this is what the main criteria for this project, main function, where we will describe in this uh, slide presentation. Okay, for this slide, we will show you the existing of the smart pill dispenser, or you can say some of that is a partial of the smart pill dispensers. All right, so we have 4 examples here. First one is an advanced medication dispenser, and then the second one, the smart medicine reminder box, and the third one, the Philips medication dispensing service, and the last one, iMedipack. Alright, so we go first at the advanced medication dispenser. This is one of the functions that you can monitor via a web page, where the supervisor can verify if the user has taken the drugs or not. They are using the ID via the RFID tags to dispense only to the correct person. And then we go to the next one, next example, the smart medicine reminder box. They are using the Arduino Uno base. Alright, so this Arduino Uno base can able to give the some of the using real-time clock module so that they can obtain data in the real time, and the user must take the pills inside the designated boxes. And then the third one, Philips medication dispensing service. This is a non-portable, where as what you can see from the figures, they need the power supply to be connected with these devices, right? So this is what we call a non-portable large piece storage, and is also have a limitation in terms of to bring to everywhere, and they have a battery backup system and stacking the cup in the sequence. Alright, so next, last one is a iMedipack. This iMedipack is monitored via a web page and disposable envelope inserted in the pill box, where this compartment will light up to notify the users. So this is mean this project have a notification, right, to notify the users, and then users needs to retrieve the pills from inside the pill box. Alright, so we go to the next. This one is the objective of this project, where this objective first is in terms of the mobile application alert, and then last one is a dispenser. Alright, so first one we want to develop, develop the mobile application, which this mobile or the system can create the pill dispensing schedule and send a signal to Arduino microcontroller at the desired time. And then the second one is alert. Alright, so these alerts can give the users can give a notification where is related to this due time on how, when, alright, it's supposed to be taken by the patient, especially, right, with the different colors. They give the different colors in terms of their notification by using some of the LEDs, where we are using these LED strips with the buzzers also to give more efficiency in terms of the notification and update the alert status when it is notified. Alright, so you can also update some of the alert via the system or at the hardware itself. And then the last one, the dispenser, where the last one is to develop a dispenser which could dispense the pills when the push button is pressed. So this is related to the mechanism. Alright, we have to consider with the mechanism when we are pressing the button so that it can properly to dispense the pills, right, at a certain angle also, and also at a certain distance. Alright, so next is hardware. Alright, this is the hardware they are using for these projects, where the first one for sure we need this kind of a microcontroller, where the type of a microcontroller already identified. We are using the ESP32, where this ESP32 is to control all the functions involved inside the system. This ESP32 Wi-Fi module is popular for its dual-core processors and integrated with the Wi-Fi and Bluetooth feature. Thus, it is suitable and perfect for the Internet of Things application. Then next one, we identify this taper motor. This taper motor is able to dispense the pills, to rotate the dispenser at accurate and fixed angle. This stepper motor is commonly used. The stepper motor which convert electrical pulse into the discrete mechanical rotation. It rotates in accurate and fixed angle increment known as step when the electrical signals are applied. And then the next one is a driver. We need this driver, or without this driver we are not able to configure this stepper motor. Alright, so to control the stepper motor, this driver is one of the most common motor driver ICs that houses an array of 7 Darlington transistor pairs. Darlington pair is a pair of the transistor where the second transistor amplifies the output current of the first transistor. As a result, it requires a low input current and produce high output current. And then next one, the DC boost converter. Since the motor driver needs a higher input current, it will increase the low input current received and produce a high output to the motor driver. Converter helps to set up or boost the voltage needed by the Arduino components. With the built-in multi-term potentiometer, the output voltage can be easily adjusted with a flat screwdriver. And then next one is the LED strip. We call this SK6812 LED strip. Act as an alert. This LED can control the entire LED strip by only using a single pin from Arduino board, since it has only 3 connectors, 2 for the powering and 1 for the data. This LED strip works for at the 5 volt. And then the next one is the buzzer. Buzzer act as alert. This passive buzzer, or as known as a piezo buzzer, is needed to alert the user for this project. This buzzer is normally found in all computer motherboard which is connected to speaker pin. Alright, to make it the efficiency in terms of the notification to the patient. That is why we have this combination of the buzzer and also the LED strip. And then next one is the pill case to store the pills. This is a part what we call, we have to we can say this one is the main part for this project. This device will include the 2 parts, which are the outer layer of the case and the inner part of the pill compartment for different time of pill consumption. And then we have a push button, where this push button to get input from the users to dispense the pill. And then a push button is a type of switch which can control an action in the machine and some type of the process. This is needed for this project in order to dispense the pill by pressing the button and trigger a signal when the button is pressed. And then we have also the LiPo power shield, where this one is to supply the power to the system independently without need to plug in, right? So that is why we need this. This LiPo power shield allows the Arduino to be fully standalone without using the USB cable or adapter for power. Besides, the shield itself is a battery charger and designed to stack perfectly on Arduino Uno or other compatible boards. It provides the 5 volt power to Arduino mainboard. And then we have last one is a LiPo rechargeable battery. Of course, we need this LiPo rechargeable battery. We don't want the what we call wear and tear, something like that, because this one is needed as part of the portable devices or portable project. As what we require is rechargeable battery, where this lithium ion polymer batteries are thin, light and powerful. So I think this one is quite enough in terms of their energy store, or also the power, and suitable with their power voltage. And the output range of this voltage is about 4.2 when it's completely charged to the 3 volt. This battery has a capacity about 1300 milliamp h, and pre-attached with a genuine 2-pin JSTPH connector. Alright, so that's all for this hardware, and then we go to the next one. Okay, this part will be explained about the software and the tools that involved in this project. The first one is Arduino IDE, React Native, Android Studio, Microsoft Visual Studio, and also the last one is Firebase. Alright, what is the function for the Arduino? Arduino is to write and upload the code, to write and upload the program to Arduino compatible boards and other third-party core, and also the other vendor development boards. Its user-written code only requires 2 basic functions, which are for starting, the sketch, and the main program loop. And then the next one is a React Native. The React Native is the framework used to create the mobile apps. So React Native is using the JavaScript framework for writing real native rendering mobile application for Android and also the iOS. It is based on React, which is a Facebook JavaScript library for the building user interface and targeting mobile platform instead of the browser platform. And then next one is Android Studio to run the emulator to test the code of the app before it's fully built. Android Studio is the official is the official integrated development environment for Google's Android operating system. And then the next one is a Visual Studio, the code editor for the source code to create the apps. Microsoft Visual Studio is a source code editor developed by the Microsoft for the Windows. And then it allows user to change the theme, the keyboard shortcuts, preference, and all extensions that add additional functionality which make the Microsoft Visual Studio is highly customizable. The source code is free and open source. It is released under the permissive MIT license. The compiled binaries are freeware and free for private or commercial use. And then we go to the last one. We are using the Firebase. This Firebase is for the database. All the database will be kept inside this database. Firebase is a platform for creating the mobile and web application developed by the Google. It is help the users to build apps fast without managing infrastructures by providing them with the functionality like analytics, databases, messaging, and crash reporting, which allow them to move quickly and safely. Okay, we move to the next one. Right, so this part we will explain about the schematic diagram. So we have a main component here is ESP32 is one part of the microcontroller, is integrated to all the components involved. We have a buzzer, LED strips, DC boost converter, motor driver, and also the stepper motor. Alright, so we look at a motor driver which is connected to the port 26, 25, 17, and 16. So the motor driver needs a 12 volt power input which required 100 watt adjustable DC boost converter to step up the input voltage. Then the stepper motor is attached on the motor driver. Right, so they attach to the motor driver. This system produce alert which come from the LED strip and buzzer. Right, so this one is the buzzer and also the LED strip. The buzzer is connected to the port 19 while the LED strip is connected to port 23. In order to get input the users, the system requires two push buttons which are connected in the port 12 and also the port 13. All the components involved are powered up by a common source which come from the 5 volt port on the ESP32 board. Besides, all the components also are grounded together into the common ground of ESP32 board. Alright, so we go to next one. This is the illustration in what we are designing. Before we want to design to do a prototype, we are using a tool or the software of this Autodesk Fusion 360 and its SketchUp software. So we managed to have this kind of almost exact size and also in terms of their what we call the design. And then we also have some of the components that related to this project. Then we managed to put the motor, the stepper motor here to be connected, to be attached together with the field dispenser. And then we are putting the LED strip here, alright, for the indicator and also the buzzer, also a part of the indicator there. And then we managed to have this push button, right? Whether you want to put in to do this push button as well as part of the manual system and also to generate to the next step. And then this one is a field dispenser where you can see that they are attached together with the stepper motor. Alright, so we have a casing, and then next this one is the roughly the prototype that already developed for this project. And then this one is an overview for the connection in terms of the prototype to make it successful. There is a lot of the components were already attached there. Alright, so next is we are looking at the overflow chart. Alright, where we will start with the user login. So user login, we log into this, and then user will select and add a patient, and then next one the user arrange the pills into the compartments, and then after that the user create or edit the schedule. And then next is mobile application send the signal to Arduino microcontroller when the time is equal to the set time. And then after that the LED strip and buzzer will turn on for the notification. And then we go next to set the patient view schedule. So we can able to view the schedule for the patient, alright, from the user's perspective. And then here the patient enter the patient ID. Alright, so normally the patient no need to do some of the sign up or process for this system, right? Just add in their patient ID, and then next we have a schedule is display for the patient. Alright, so where this one is patient press the notified button, so that it will send the signal to Arduino microcontroller to, and also this microcontroller will send a signal to the mobile application, so that at the same time in the real time the mobile application will update the schedule status. And then the last one, the last cycle updated, is that notification will be sent to the user to prepare the next schedule, right? If not, the patient press the dispense button, and then the stepper motor rotate to dispense the pill, then the end of the system. So if you look at this system is involved together with the what we call the software part and also the hardware part arrangement. So I would like to show you the project demonstration. So this part will be explained about the limitation during this project development, right? So we have several part of the limitation where I cannot say that all the problems has not been resolved, right? All the problems, all the limitation has been resolved in the 13 of the techniques and also the solutions. Alright, so we have several here. Motor rotation, motor signal, fire-based rotation angle, input power, and then we have another more. I will show you to the next slide. Alright, so we go to the first one, the motor rotation. About the motor rotation, where the motor rotates slowly during the initial phase of the hardware development. Each component is tested individually and they are integrated together after all the components are fully functional. The problem appears when the other components are tested together with the stepper motor. The motor seems to rotate slower than before when tested separately. This problem occurs due to insufficient the power received by the stepper motor to rotate uniformly at a specific angle. In order to counter this problem, a step-up transformer is added into the system. Alright, as what you can see here, to increase the input power for the stepper motor. The type of transformers used for this project is a 100 watt adjustable DC boost converter, which enables the user to change the desired input power easily by adjusting a small screw on the board itself. Alright, we move to the next one, the motor signal. The motor cannot be interrupted. Alright, we can say this one is the problems occur inside of the software, where this one is part of the Arduino IDE itself, related to the program, where the stepper motor does not rotate when other component or function are integrated together inside the source code. The problem occurred because the delay method inside the stepper motor cannot be interrupted with any function or delay method, which make the stepper motor cannot compute its function since it is blocked by the others. Beside the Arduino compiler computer, the code in sequence, so any interruption or the blockage will affect the flow of the process. To overcome this problem, the stepper motor function is separated inside the source code with other function for the stepper motor works independently. So this one is an example that has been encountered for this problem. Alright, we go to the next one, ESP32 Firebase. This one is regarding to data transfer. They have some of the problem in terms of the communication in between of the ESP32 and also the Firebase software, where the ESP32 is supposed to transfer and receive the data from Firebase via the Wi-Fi connection. The problem is the ESP32 can only send the data but cannot read the data from the Firebase, although the Wi-Fi connection had been established all the time. This is because the Firebase library used inside the Arduino compiler, which is a Firebase ESP32, does not up to date. As what you can see here, this one is the part of the version already up to date. Hence the previous library needs to be deleted first and download the latest one to avoid the syntax from the both libraries and clash with each other. Right, so we go to the next one. It's about rotation angle, where this is related with the dispenser and also the stepper motor. Alright, so although the stepper motor has been supplied with enough input power, or we can say this one is well functioning, the rotation angle of the dispenser is unstable due to the improper connection of the stepper motor with the dispenser. The previous connection to be loose a bit, which resulting the dispenser cannot rotate uniformly based on the stepper motor due to the grip loss. To overcome this problem, the stepper motor is glued by using the hot glue gun. Right, at the moment we are just use hot glue gun for the part of the prototype. Maybe we can do with the other alternative to make it more robust in terms of their attachable with the stepper motor and also the P dispenser. Alright, we want to avoid any slip away during the rotation process. Right, so you can manage all the what we call we cannot say it's managed. We can say this one is able to rotate properly to dispense the pill. Alright, so next one is input power. During the initial development, the dispenser needs to be powered up by using the USB cable or 12-volt adapter, which will limit its portability due to wired connection. Hence, the power shield together with rechargeable LiPo battery, we are using the rechargeable LiPo battery being added into the system. By using this method, the dispenser can be carried around and working normally as the power shield itself is a battery charger and designed to stack perfectly on the ESP32 board. Both the components provide the 5-volt power to the board with ease. This battery can last long for about 5.2 hours, ideally based on this formula. We are managed to calculate this by using this formula to estimate, right? To predict, to estimate in terms of the usable of this rechargeable battery. Besides, this battery also can be fully charged for about 2.6 hours based on this formula. Alright, so next we move to another limitation. We have a network problem. Okay, the ESP32 Wi-Fi connection, when the device is moved away from one place to another, the network would change accordingly to the availability for a certain area. Although the Wi-Fi signal is available around the device still needs to connect with the same configured network inside the source code. To overcome this problem, user can share their network using the same credential configured inside the source code. So the ESP32 will be connected automatically when it detects the known network and working normally. Else, the user would have to configure the network detail inside the source code according to the available network and upload it into the board. Alright, so the last one that problems has been encountered for this project is a mobile application. Alright, mobile application interfaces, where this is a part of the navigation of these mobile apps. During the initial design of this application, the apps seems to be complicated for a senior citizen, since it consists some function that required a lot of steps to use it. In order to capture this problem, a patient view screen had been created for the senior citizen to use with ease due to its less complexity for them to navigate through it. They just need click the patient sign in at the login screen and enter their unique IDs. The schedule of their pill intakes will be shown instantaneously. Alright, so we move to the next one. Alright, so this part will be the last slide that we conclude based on all the project has been starting from the objective, the problems and whatsoever. So as what you can see from the slide is some of the summary based of this summary of the conclusion based on this project, where this project is proposed and IoT-based smart pill dispenser with a monitoring system, especially for senior citizens to have on their medication intake with the correct dosage at a preset time. This system allows user to manage and create the pill schedule for the senior citizen by using a mobile application. This mobile application will communicate with the Arduino via the Firebase, Firebase database, which act as an intermediate database for both components. Once the current time reaches the preset time, the dispenser will alert the senior citizen by using LED strip and buzzer. Besides that, this LED strip can change into the different colors for every 30 minutes to remind the senior citizen about the due time of the medication intake. The alert will stop once it had been notified by pressing a push button, which results the data being recorded in the mobile application for users' acknowledgement. A stepper motor is used for this project to rotate the dispenser at the desired angle once a push button is pressed. This system is unique and different from previous systems since it offers a colorful indicators to alert senior citizens and it's also portable and user friendly. When we talk about the notification but not to forget, we also have the buzzer component to give the indicators or what we call the notification to the users and also to the patient itself. And emergence of the Internet of Things especially brings a whole new class of the application and higher efficiency for existing service. Applications, the specific requirement as well as the connectivity and communication ability of devices have introduced a new challenge for Internet of Things application, where the Arduino has been vastly used in the Internet of Things technology. I think that's all for my part. Thank you very much and Assalamualaikum.